Okay, today we are going to talk about another type of functions, which is cubic functions. So you're going to open your notebook to page 56, and we're going to label, not 56, sorry, 58. We're going to label 58, 19, not 19, let me check what the number is. 24.3. We're skipping all the way to 24.3. That's what number it technically is in your book. So page 58. 24.3, graphing cubic. The title on your tab says graphing cubic and square root functions. We're going to do cubic today, and we're going to do square root the next day. But that's the title for 58 and 59. Let's go ahead and label 58 and 59 that. I'm going to do both right here. Okay, so you're going to need your calculator. As you can see, you got one on my screen. You're going to need to either write on 58 or print off the foldable, or make one with a piece of paper. But we're talking about cubic functions today. A cubic function is a little different than what we talked about before. It's got to the third power cubed. Okay, we're going to graph these. We're going to talk about each of the pieces, relative minimum, relative maximum, and then the x and y intercepts. You're going to need highlighters. You're going to need every color except for yellow today. Okay. So the first thing we're going to do is create the graph. And we're going to use -2, -1, 0, 1, and 2. We're going to cross out the last one. We're going to use those numbers every time. Okay, so I'm going to press y equals and clear anything out here. I'm going to type in negative x to the third power. I need to go over so it's not still up there. And then plus 3x squared. Go over minus 6. Then second graph, like we've been doing forever. Okay, I'm starting with -2, so I'm going to go up to find -2. -2 is at 14. -1 is at -2. 0 is at -6. 1 is at -2. No. 1 is at -4. 2 is at -6. Okay. So -2, 14. I cannot graph that. -1, -2. 0, -6. 1, -4. 2, -6. I'm just kidding. I do need to graph 3. We're going to have to graph every single one of them in this one. There's a reason. You're going to see the reason. So 3 is -6. I messed up. This should be -2. Can't read the computer screen evidently today. So let's regraph this one. It's 2, -2, and then 3, -6. So sorry. Okay, so this looks crazy. A cubic function, though, you're going from left to right, going up, down, then it goes back up, and then it goes back down. You need to extend this all the way. It's going to look like this. It's going to go either up or down first, and then it's going to curve around. That's what a cubic function is going to look like, okay? Now the a value is the number in front of x to the third. There's nothing there, or there is, but it's a negative. We put -1, okay? The relative minimum. A relative minimum is, remember when we had vertex and I said it could be a minimum or a maximum? It's one of the curve points. It's either this one or this one, and it's the one that's the smaller value. So the relative minimum is here because that is the smaller value. So the relative minimum is 0, -6. Came from right here. That's the relative minimum. Okay, and grab blue. The relative maximum is the other, it's called an inflection point technically, meaning that's where it changes, is here, because that's the maximum one, and that is 2, -2. 2, -2. So that's the new part, is finding the relative minimum, relative maximum. Now let's do what we've done in the past, x-intercept, y-intercept, in behavior, domain, and range. The x-intercept is where it crosses the x-axis. In a cubic function, it will always have at least 1. It might have 1, it might have 2, it might have 3, okay? The x-intercept in this situation is right here. We're going to have to guess it. We don't know how to solve it. It looks to me like it's close to -1.5. The y-intercept is where it crosses the y-axis. If you don't see it on the graph, I promise it has one. You might have to grab your calculator and find it, but this one is on the graph. The y-intercept is 0, -6. In behavior, when x approaches -infinity, y approaches, this is the left side, it is going up, so y is positive infinity. When x approaches positive infinity, which is the right side, y is going down, so it approaches negative infinity. They will always be opposites for cubic functions. Domain. This is going both left and right, so it is all real numbers. You can either write ARN or you can make the symbol. I'll show you the symbol again. Range. It is going up and down. So range is also all real numbers. For every cubic function, the domain and range is all real numbers. I'm going to open this up and do number 2. Number 2. We're going to put the same values in there. -2, -1, 0, 1, 2, 3. We're going to go to y equals, clear this out, and type it in. So x to the third minus 3x squared plus 4. Second graph. Okay. -2 is at -16, so I probably won't be able to graph that one. -1 is at 0. That's one of my x-intercepts then. 0 is at 4. 1 is at 2. 2 is at 0. 3 is at 4. You are going to have repeats. You should. 0, 0, 4, 4. It's not quite like a quadratics repeats, but I cannot graph -2, -16, so I'm going to have to graph -1, 0 first. Then 0, 4. So this one's going to go up, then down first. 1, 2, 2, 0, 3, 4. So left to right, it goes up, then down, then up. And then I got to go connect and finish this other one. You shouldn't just have an N or something. You need to connect the whole thing. All right, A. There's no number here, so it's understood 1. Relative minimum. It's either this one or this one, and I need the smaller one, the one that's lower. So that one is 2, 0. Came from right here, 2, 0. Relative maximum is got to be the other one, the other inflection point. And that one is 0, 4. The x-intercepts, there are 2 this time. Remember, there can be 1, there can be 2, there can be 3. there has to be, it can't be none on a cubic function because it goes up and down. One of them is negative 1, 0. The other one is 2, 0. They were here and here. Okay, and the y-intercept, again, there has to be one of those, even if you have to look at your calculator to find it, but it's right here. It is 0, 4. Okay. In behavior, when x approaches negative infinity, y approaches, it is going down, so it's negative infinity. When x approaches positive infinity, y is going up, so it approaches positive infinity. The domain and range are all real numbers for every cubic function. I want you to pause the video and try 3, 4, and 5, and then unpause. All right, number 3. Hope you paused it. Negative x to the third plus 3x squared minus 5, second graph, negative 2, 15, negative 1, negative 1, 0, negative 5, 1, negative 3, 2, negative 1, 3, negative 5. I can't graph negative 2, 15. Negative 1, negative 1, 0, negative 5, 1, negative 3, 2, negative 1, and 3, negative 5. So this one, left to right, it starts here and it goes around, and I need to graph all the way up. Okay. A is negative 1. The relative minimum is this one, which is 0, negative 5. The relative maximum is this inflection point, which is 2, negative 1. We only have one x-intercept this time. Like I said, we could have 3. And it looks like it's not exactly at negative 1. Negative 1, let's say 0.1 or something. Because it's not exactly at negative 1, but it's a little bit, whatever. If you have negative 1.5, that's fine too. All right, y-intercept. Zero, negative 5. And then in behavior, when x approaches negative infinity, y is going up, so y approaches positive infinity. When x approaches positive infinity, y approaches negative infinity. Domain and range is always all real for cubic functions. Okay, if you did not pause this video to do 4 and 5, do that now. Okay, so y equals, clear it out, x to the third minus 3x squared minus 1, second graph, negative 2, negative 21. We definitely won't be able to graph that one. Negative 1, negative 5, 0, negative 1, 1, negative 3, 2, negative 5, and 3, negative 1. Can't graph the first one, so negative 1, negative 5, 0, negative 1, 1, negative 3, 2, negative 5, 3, negative 1. So left to right. Here we go. The A value is 1. The relative minimum, remember you've only got two options, it's either this point or this point. It's the lower of those two, so it's this one. That is at 2, negative 5. The relative maximum, it was either this one or this one. It's larger here, so that one is 0, negative 1. The x-intercept, there's only 1 this time. Could be 2, there could be 3. It's not quite at 3, it's a little over 3. So let's say 3.2 or something. You can say anything, 3.1, 3.2, 3.3. You don't know how to solve it yet, so I get that. Okay, and the y-intercept crosses at 0, negative 1. Okay, now in behavior, when x approaches negative infinity, y approaches negative infinity as well. It's going down. When x approaches positive infinity, y approaches positive infinity. Domain and range is all real numbers. Okay, and again, if you have not paused the video to do 5, do that now. All right, number 5. Y equals clear x to the third minus, hang on, my mouse isn't working, minus 3x squared, let's move it so you can see it now, plus 1. And second graph. Negative 2, negative 19, again, we probably won't be able to graph that one. Negative 1, negative 3, 0, 1, 1, negative 1, 2, negative 3, and 3, 1. We can't graph this one, but we can graph negative 1, negative 3, and then 0, 1, and then 1, negative 1, and then 2, negative 3, and then 3, 1. It's going to cross the x-axis 3 times. 1, 2, 3. Okay. The A value is 1. Relative minimum, it's either this point or this point. So it's the lower one. That's the minimum. That is 2, negative 3. The relative maximum, the larger one, that is 0, 1. The x-intercept, it crosses 3 times. It crosses here. That's smaller than 1. So let's say negative small, it's between 0 and negative 1. So let's say negative 0.5, comma 0. Okay, it crosses again here. So 0.5, 0. And it crosses again here. Almost at 3, but not quite. 2.5, 0. Crosses in 3 places. The y-intercept. Now, why in the world I gave you so much more room for the y-intercept when the x-intercept had 3 of them, I don't know. Because you only ever have one y-intercept. The y-intercept is 0, 1. Then in behavior, when x approaches negative infinity, y approaches negative infinity. And when x approaches positive infinity, y approaches positive infinity. The domain is all real. The range is all real. We are gluing this in your notebook on page 58. You will do homework now over cubic functions. We will do square root tomorrow. This goes on page 58 of your notebook.